Permutations as ordered selections. So here we're going to look at arrangements where the order's important. So if you were to put your 4-digit passcode into your phone, let's just say it was 1, 2, 3, 4. Would putting in the same passcode as 4, 3, 2, 1 work? Well, no, it wouldn't work. So in this case, the order is important in which you put the passcode digits in. And when the order is important in an arrangement, we call this a permutation. This is called permutation. And let's have a look at how we could maybe calculate how the amount of arrangements you can put your passcode into your phone. So if there was a 4-digit passcode, you would have 10 digits to pick from in the first one, followed by 10, 10, and 10. And using the fundamental counting principle, we just times all these together, and we get 10,000 possible arrangements or permutations for the passcode on your phone. Now, what if the digits were to not be repeated? Well, you'd have 10 options in the first one, followed by 9, then 8, and then 7. And timing all of those together is just going to give you 5,040 possible combinations for your passcode. Now, when we look at permutations, there's a special notation we can use, and it has the form of NPR, where N is all your possible selections, and R are the things you're selecting. And the formula for NPR is actually n factorial over n minus r factorial. And how can we use that in the example we just did, where the digits were not repeated? So again, we can only use this if there's no repetition. So here we had 10 digits to select from. These are all our selections. And we wanted to select 4. So we could have written this as 10p4, which is the same thing as 10 factorial over 10 minus 4 factorial, which is 10 factorial over 6 factorial. And a nice way to simplify factorials is actually writing it as 10 times 9 times 8 times 7 times 6 factorial. So instead of writing the last ones out, over 6 factorial, and the 6 factorials will cancel, and you can see we're just left with 10 times 9 times 8 times 7, which is exactly what we had before, and we get 5,040. So this is when you're not allowed to repeat any items. If you're repeating items, like in our first example, it just becomes n to the power of r. And in this case, we had 10 things to select from, which we could repeat. And we wanted to do it 4 times, and 10 to the power of 4 is 10,000. So they're the 2 ways in which we can use our things when arrangements are important. So we have this, and we have this to use.